Good morning, good afternoon, good evening, depending on where you are. I am Inderpal Bhandari. I'm the Global Chief Data Officer of IBM. And I understand that we have a mix of practitioners and executives. So I thought I would get to enterprise transformation. But by way of setting the background, I'll give you a sense of data and AI and how things have been transforming, as well as give you a sense of my own journey as I embarked on that in this particular space. So let's start with the first slide on the attributes of AI. So just to give you a sense of when I talk about AI, what we mean. An AI system must have four attributes. A, it has to be an expert at something. It could be an expert at a particular domain, like a medical domain, like oncology. It could be an expert at some kind of process, like marketing or supply chain or some business process like that. It has to be an expert at something. Secondly, it has to be able to express itself in a natural way for people. And the meaning there is just like we communicate, either through language, it could be text, eventually, even gestures, drawings, etc. An AI system has to be able to do that. And I'll explain in a minute why with a couple of examples. But the bottom line is that if you go with an AI system that has to be able to explain itself to a decision maker, the decision maker is not likely to be technical. So the AI system has to be able to communicate with the decision maker in a natural way. And that's why that's important. Now, there are, systems that are used in an instantaneous sense, like algorithmic trading and so forth. And there is no decision maker in the loop. But even there, I would submit that the decision maker is there, but in a way it's kind of withdrawn because the decision has to be made instantaneously while you're on the trading floor. But it's already been baked in because the way those systems trade with small trades and so forth, but lots of them, the risk is already diversified. So in any case, that's I digress. So let me get back to AI systems. So the other thing with these AI systems is they have to be educated. You educate them. As much as we learn from them, they learn from us. And it's different from systems where you essentially have to write code or even business rules and so forth. In this case, you're showing them data, you're showing them edge cases, you're showing them exceptions, and that's how you're teaching these AI systems to learn. So they're capable of being educated. And finally, the last E, I use these four E's to describe the attributes. They evolve and they learn with every new input that we give them. And that's where the real power comes in, because what these systems are then able to do is they're able to scale very rapidly and keep up with the data explosion. So for instance, medical knowledge, that's basically doubles in a very short period of time. The journals, etc., that you have, I think it's every 72 days or something like that. The knowledge itself is just exploding. So there's no way a doctor could keep up with all that. Our estimate was that a doc would have to spend 160 hours a week just reading journals, so it leaves no time to see patients. But that's why you need these systems. That's the reason why they're so valuable. That's the reason why they are becoming as prolific as they are today. Now, why did I say that they need to work with a decision maker? For this, I'm going to take you back in time, almost 2 decades, actually a little over 2 decades. In 1990, I had joined IBM for the first time as a research staff member, the Watson Research Lab. And I ended up doing this project for the NBA, the National Basketball Association, and it ended up being used by all the teams of the National Basketball Association. Essentially what it did, it was called Advanced Scout. Essentially what it did was it helped the coaches come up with game strategy. And it was especially useful during playoff games, when they were playing a series of 5 games or 7 games and they could get knocked out. It became very, very useful. The first time that Advanced Scout came up with a counterintuitive pattern, and it would suggest things like, you need to start these players, or you need to switch this player out when this other player is on the floor and they're running this kind of play. So essentially, all these different combinations, which are very difficult for humans to keep track of, it would study all that using the historical data as the series unfolded, and then it would make these recommendations. And so the first time it made a real counterintuitive recommendation. It asked the coach of the Orlando Magic at that time. They were playing the Miami Heat, which was the dominant team. They were down 2-0 in the playoffs, and the program essentially suggested that the coach should start two backup players, the backup point guard and the backup forward. And for those of you who understand basketball, you know these are pivotal positions, especially the point guard. And the coach called me and said, this is very difficult for us to make this decision, because if we make the wrong decision, not only will we lose the game, but we'll also look foolish. We'll probably get fired. We'll lose our jobs, our careers, etc. And then I realized that the issue here is when you just provide the statistic or the finding, the system is not able to explain what's going on. So in those days, 2 decades ago, the way we solved the problem was we actually put in the video clips when those circumstances unfolded, so the coach could see exactly what happened when those two players were on the floor in the 2 games they'd lost. And then they understood what was going on. They understood that backup point guard was far more energetic than the dominant point guard that Miami had, who was the best in the league. But he couldn't keep up with this guy, and so it would tire him out. That opened up the outside shot, etc. So then, once they understood that, they began to realize that this was a good move. They made the change. They won the next 2 games. They lost narrowly in the last game. So it was a very compelling demonstration of what things could do. But I understood we were missing the context. So flash forward now, 20 years later, and what you see is that these systems, these AI systems, they can actually not just process structured data and come up with findings, as in those days of data mining 2 decades ago, but they're able to process data of any media, and they're able to come up with these findings. So these systems, essentially, I'll give you some examples from Watson. In sports, Watson can essentially identify the distance between players, how fast they're moving, whether they're doing a fist bump, what's the decibel level of the crowd reaction. And so all the things that I talked about setting context, these systems are able to find automatically today. And so when you put together that power of keeping up with the scale of the data explosion, as well as this power of establishing the context around an event, you understand why these AI systems become very, very powerful and why they are so relevant and so needed for what we have to do today. So with that backdrop, let me now switch over to the enterprise and essentially what does it mean to transform an enterprise and why are data and AI relevant. So now remember in the previous, the flashback that I just gave you, the things we were worried about there was I was trying to solve the problem as a researcher of, hey, there's going to be this data explosion. How do we keep up with it? Everybody's going to need to keep up with it. I firmly believe that. And I picked the NBA coach as an example to make the point. Now, flash forward 20 years, and it's all true. Data, affects everybody's life. And in the context of a large enterprise like an IBM, it's not immediately clear what you're going to do with AI. But then when you think about the fact that it affects everybody and every job, if you start looking at it that way, then you realize that the opportunity for AI has to do with infusing artificial intelligence into every major business process that a large enterprise has. And when you think about that, you further then realize that there are literally hundreds of thousands of such decisions being made every day. If you assume that everybody, every employee in a large company like ours is going to need to use AI, you reach that conclusion that there are hundreds of thousands of these decisions. You have to infuse AI into every business process. And then that's the journey that we went on in IBM, and I joined in actually December 2015, but I spent 2016, 2017 working on a data strategy, which essentially supported our business strategy of becoming an AI company, and then using that as a showcase for our clients and customers so everybody could see how you would infuse AI into a business process as well as at scale across a large enterprise. So let me give you a few more thoughts on that. So in terms of our approach, we developed a blueprint as we got our own experience with regard to changing IBM, and we realized that you would have to obviously apply technology, in this case, cloud and AI technology. You'd also have to essentially harness the data, make sure that the data was ready for AI, and to do that, you would have to do things like collect the data, organize it, clean it, etc. And it became quite a challenge because as you start going up that ladder of data to AI, and you get to the stage where you're able to run hundreds of thousands of, say, very sophisticated and very compute-intensive deep learning experiments, there are all kinds of aspects that you have to worry about, including the proximity of the specialized GPU servers with the actual data itself and its location and the networking speeds. And so you kind of almost go, you come up the ladder and then you go back down the ladder because you want to make sure that everything is going to be able to work effectively and really, really fast. So data and technology, those are two major pillars, have to go hand in hand. But also people, they have to be comfortable using AI systems. And if they're not, it's not going to be successful. As well as the point I made about infusing AI into every business process. If you don't change your business process, for instance, if your supply chain is going to keep running the way it always was, it doesn't matter whatever you glean from the data, it just won't get applied and people won't use it. So these four pillars have to be brought together at the same time. You might think that in a sense, as you start applying this to a large enterprise or a corporation, it's a little different from what work I did with the NBA. But I would actually say that there's a parallel. When you actually applied it to the NBA, what we found was they didn't actually have the play-by-play data. So we worked with them to develop the data capture systems, which are, you still see them, those laptops at courtside. But people are actually capturing the play-by-play there. And then once we did that, then after that, the technology, those days it was all client server. So we had to set that up. And then the people, they used to have video coordinators. They became data and video coordinators. And then the entire process also changed because they would wait for the data at the end of every game and then analyze it. So they changed their process so that they could work that into their system. So you see this no matter whenever you try to make an impact, you'll see these four aspects play out in the context of a large enterprise, obviously much more scale. Let me go to the next slide and give you some sense of my organization and what it looks like. Well, we've got obviously the technology arms. These are the folks who worry about cloud, AI, deep learning. So there are two senior leaders who report into me on that. In keeping with our conversation about people, business process, there's also an adoption arm. So these are the folks in my area who, once given that we've built this central data and AI enablement platform, they can go off and start working with their counterparts in other business areas. They're fully empowered to go off and just make the difference if the other side is so inclined as well. And that bottom-up approach is very, very successful in moving things on rapidly in this context, because adoption is a key aspect of what one needs to do in an enterprise. And then governance is a huge aspect of being a data officer and preparing the company for AI, because you have to standardize data. So some critical data, like the data about our clients, you can't have ambiguity there, right? You can't have a company being referred to as company X and in one data file, and then as company XY in another, or something like that, right? So you can't have all that. And so that's why the standardization of certain key data like your client data, because eventually if you want to grow your business, you worry about your clients. You also worry about your brands and offerings, so that data. You worry about who's supporting those brands and offerings to deliver value to the clients. So then it has to be also your workforce data and so forth. So you kind of back into which data to govern and standardize, because every time you standardize and govern, you put a speed bump and you reduce the speed of innovation. You also don't want that. So that's the balancing act. I think those are the main areas. There's a couple of other areas, but I won't touch on them in the interest of time. I think you get the idea. Let me go to the next slide and give you a sense now of essentially what it means from a technology standpoint. From a technology standpoint, our approach has been one of meeting the data where it is. So in that sense, we have espoused a hybrid multi-cloud approach. That's why at the bottom, you see all the different major cloud vendors listed there, as well as private cloud, on-prem, etc. Because we've realized that to really go after a complex enterprise, there are reasons why people do things where they do them. So if you're doing something in Europe, there's a good reason why you're doing it in Europe. If you want to do something on-prem, because maybe it's very sensitive and you want to do it on-prem. So in any case, our approach is we're going to meet the data where it is, but we're going to have some principles. We'll allow people to ingest the data once, access it anywhere, but appropriately. Similarly, write the code once and then run it anywhere, but appropriately. So I'll talk a little bit about these terms. So in terms of the foundation, we acquired Red Hat, and they have a product called OpenShift that runs on Linux. And OpenShift essentially gives us the portability across all these environments. It is a managed service based on Kubernetes, obviously open source Kubernetes, but it gives us that portability across all these different platforms. And then on top of that, we have layers of abstraction built in the form of our cloud packs. So there's a cloud pack for data, for automation, for multi-cloud control, which gives you a single pane of glass, which you can control all the stuff that you have running across all the other clouds. And what this allows you to do is to be very consistent about some of the non-functional requirements of your code, of your engineering. What I mean by that is security, privacy, all the other policies that you have to make sure in today's world that they're going really well. You have to be able to do that consistently. Consistently doesn't mean the same way. It could actually be quite different. So for instance, if you log into one of our systems from the US and you're authorized to get some data, you might get it while you're in the US, but if you log in from Germany, even though you have the authorization for the data, you won't get it because the German regulations could be different. So the key point when I say appropriately is basically tailoring to all these different regulations. But so you can imagine the complexity that comes up with all this, which is why that layer of abstraction sitting on top of OpenShift is extremely important. And it simplifies the task for the developer so that they are able to do their, you can think of it as DevSecOps. By sec, I mean security, but I'm really capturing all the non-functional stuff in there, and makes life easier for them to govern this across such a global enterprise. So that's from the technology angle. Next slide, please. And just to give you an example of how this looks, so now you've got this central data and AI enablement platform. And even though I say central, I mean it's logically centralized. Obviously, with my preceding remarks, you understand that it is a distributed, multi-cloud setup, including private clouds and on-prem, and it's global in nature. And then every business process we've attacked in terms of infusing AI into them. I'll give you a few examples in a minute, but you can see we pretty much cover everything from supply chain, procurement, finance, marketing, my own area, etc. And there's a tremendous amount of scale that we've reached now in terms of inside the company as to what we're able to do with this kind of enablement. Because now every department, they don't have to build their own expertise. They can tap into what we've got, and they're able to go get up and running very, very quickly. Next slide. I'll just quickly talk about this application and the next one, which has to do with the supply chain. Automated metadata generation, very hard problem. This has to do with one of my own processes. You get some new data, You put it in some kind of data lake or data store. Business side doesn't understand what's in there because you don't have the business metadata to explain it in business terms what that data is about. So then people can't use it. What we were able to do is essentially automate the generation of that metadata using a combination of our custom deep learning stuff that we did using specialized GPUs, etc., plus tapping into our Watson natural language classification system. And now we've got these pre-trained networks that are custom that our clients can also use of. But essentially, it cut the cycle time of creating this stuff by 90%. So you can imagine the impact just because this is so fundamental to anything that you do end to end. You can imagine the impact that it had across the board, across all our processes that generate data. Next slide. This is another good one because we have our supply chain, which is global, and we've always had an approach to assess the risk. We automated that using AI when we infused AI into the supply chain process. Essentially, you can visualize it as having a map of all our key suppliers, and then anytime there's a major event like a political event or a weather event, we're able to overlay that data and then come up with essentially recommendations as to what's going to happen to the supply chain and anticipate the risk and be proactive and act very quickly in terms of finding backup suppliers or canceling routes, changing routes, doing things like that. When COVID hit, COVID-19, we were able to overlay the COVID-19 data on top of this. And then we decided actually that would be valuable, not just for our supply chain, where they are able to make the judgments about suppliers based on incidents of COVID and where the supplier is located, but also every other department. So, instance, our finance department, they're interested in our major customer location. And again, the same kind of reasoning you can have if you see that there's a lot of the incidence of COVID-19 are very high, they're going to be impacted and you can make adjustments. So gives you a sense of the kinds of work and projects that we do. And essentially, this enterprise space is very rich in terms of coming up with new methods, new techniques, and applying them to real world problems at scale. And for that kind of work and that kind of data, a large enterprise like an IBM is a tremendously challenging and rewarding place to be at. So let me open it up. I know we have 5 minutes left. Let me open it up for questions.
Inderpal, you have 2 questions in the queue. The first one is, how are hybrid multi-cloud platform and the AI for problem solving connected, or are these separate topics?
So to that one, let me just quickly address that. If you take something, just go back to one of the examples I talked about, right? Let's take supply chain. There literally are thousands of data sources to get that data and piece it all together before you're able to make some judgments and assess risk and apply AI and so forth. So, and if you think about where the world is going with all the edge devices and all that, that's going to be just more and more prolific, that you're going to have this tremendous diversity of data sources, and they'll be globally distributed and so forth. So this whole model where you're going to think that from a data standpoint, I'm just going to bring it all together in one major place and get working on that. I mean, might be able to do it in some cases. In many cases, you may not. The multi-cloud, just makes it much easier to be able to address that space. And when you throw in the fact that different countries will have different regulations governing the data, it becomes even more relevant. I mean, that's in fact, I would argue perhaps is the only way to do it at scale, especially as things unfold. So they're all related. And then obviously you need to have that data foundation to be able to run AI on top of that. So that's the reason why I think those two are related. The good example is the supply chain one that I have in the deck. And if you can look at that, I think it'll give you some thoughts. What's the next one, Carol?
The next one is, in an AI world for fantasy sports betting or AI algorithms for financial investing, how can we as individuals realistically compete?
Oh, that's a very, very good question. That is a very good question. So if you've got very sophisticated systems and you have data available at scale, this is a very deep philosophical question. I mean, in a sense, you're asking the question when you the classic example is in finance, right, where you've got the institutions and you have the retail investors, and there's always this concern that the retail investors are going to be at a disadvantage because you just can't compete with all those sophisticated systems. And I think this is one of those questions where we really don't have time to answer it. I do think, I mean, my own opinion on this is that I do think it needs to be addressed, and I think the right way to address it is essentially by letting people harness the same types of technologies and access to data, so you level the playing field. In many cases, people control. They actually they're the ones generating the data as well. So I think this is still to be played out, but it's a valid concern, a deep concern, and we don't really have time to go into all of it.
Next question is, what are the pillars or basic principles that a small company should follow to become an AI-based organization?
I think the blueprint slide that I put up, I think that'll be useful, just to keep those four major pillars in mind. And because, like I said, even in the case of the NBA example, we had to do that. So I think those are four major pillars. I think the other one, I kind of alluded to that, but it has to do with the major data sets that you have to harness and standardize, and those are being client offerings of brands, workforce, and your financial data. And you've got to make sure that those are in shape for AI. And you can just think of usually the simple things are no duplication, no ambiguity, etc. But it gets much more complicated the more complicated the enterprise is.
Due to time, this will be the last question, Inderpal. How do you handle setting expectations when you're starting a high potential AI project within IBM?
Yeah, so I don't actually, you can go the project approach, right? The project approach usually kind of leads to a one-off type of thing. What I try to do is set a strategy, the data and AI strategy for the company, but I align it very carefully with the business strategy. And what I mean by the business strategy, it's how the company plans to make money, not how it makes money today. So you kind of look ahead. In the case of IBM, it was the cloud and cognitive. That's how they plan to make money, even though we made money of mainframes, middleware, et cetera, et cetera. So my data strategy essentially became one of enabling IBM itself to become an AI enterprise, right? Totally aligned with that. If you do it that way, then you're writing all the funding, all the strategic emphasis, et cetera. If you go project by project, and in some cases you have to, I'm sympathetic, I understand, you do have to, but try to be as aligned as possible, at least to a major business initiative or some business initiative right up front, as opposed to thinking from the technology out, think from business in. Thank you.
Okay, that's all the time we have for today. Thank you very much, Inderpal.